In this lesson, we are going to introduce the idea of things being inversely related. Inverse variation is what this is called. So they're inversely proportional kind of. There's a way to kind of set up this thing as proportions, but it's really pretty tricky and very, you have to set it up a certain way and there's no room for error. So I think there's an easier approach to this, but the idea of inversely related objects means as one item goes up, it causes another item to go down, right? So for example, if you have 5 machines working and it takes 12 days to complete a job, then all of a sudden, if you have 8 machines, it should take less time. So more machines, less time. So that's inversely related. So I'm going to kind of not take the proportion approach because it's pretty tricky and I think there's a better way. Okay, and this better way is down here, where we're going to solve it using an equation and just basically plug things in, very similar to what you would have seen in a direct variation. So an inverse variation looks like this. A direct variation is you take this constant and you multiply it by x. But if it's an inversely related, then you're going to divide it by x. Okay? What you are typically given is you are given an example of an x and a y, and you use that x and y to figure out a constant, right? And then you might know a different x or a different y, and you use this equation to solve your problem. So I'm going to use that up here. All right, so I'm going to say that if 5 machines takes 12 days, I would consider my 5 machines my x and my 12 days my y, right? As the machines increases, it causes my days to decrease. So my equation would look like this. I'm going to do my inverse equation. So 12 equals k divided by 5. Okay, and then I'm going to multiply 5 over to the other side to get k by itself. And so that is 60 equals k. And sometimes there's meaning behind that k. I can make sense out of it, and sometimes there's not. I'm not even going to worry about it. So my k is 60. So what that means is my equation that I have looks like this. Okay, from here on out, no matter what this problem kind of throws me. So no matter if they give me a couple different examples, I'm always going to go back now. Once I've found my constant, I'm always going to go back to this equation and either plug in x's and y or y's and solve for the other. So on this one now it says that if we bump it up from 5 machines to 8 machines, how many days is it going to be? So that's my new x. So I'm looking at y equaling 60 divided by 8. And if I divide that into a calculator, I'm going to get 7.5. And that is my y. So how long will it be? We're looking for the y value, so we're looking at 7.5 days. Okay, so it's always a 2-step kind of process, right? So let's do another one. So we have a 10-inch diameter gear is in a mesh with a 5-inch diameter gear. Okay, so if the larger gear, which is this one, is rotating at a speed of 25 revolutions per minute, so this one's going 25 revolutions per minute, how many revolutions per minute is the smaller one going? Okay, so let me kind of organize my thoughts here. So if I have, I'll kind of treat it as coordinates, so I really can look at an x and a y. If I have a 10-inch and it's rotating at 25 miles or revolutions per minute, then I want to shift to a 5-inch. How many revolutions per minute would I be looking at? So I'm going to use this xy to figure out my k, and then I'll plug in that x. So my original equation, my generic equation, looks like this. My y value is 25 equals k divided by 10. Multiply the 10 over to the other side so they cancel. So my k equals 250. Okay, so I got my k, which means I have my equation of 250 divided by whatever x gets thrown my way. And they're giving me an x value of 5 this time. So 250 divided by 5 is 50. Okay, so if we make it smaller, so now I can kind of logic this. If I kind of make this smaller by a factor of 2, it increases this by a factor of 2. So this one went down by a factor of 2. This one went up by a factor of 2 because it's proportional. It's inversely proportional. But I don't know if I would have just kind of seen that naturally. All right. Okay, so last couple. Says we have a landscaper needs a 5-person crew to complete a commercial job in 20 hours. So 5-person crew is my X, and this is my Y. So if I need to, 5-person crew gets the job done in 20 hours. So there's kind of a sample for me. How many hours will it take to complete the project of the following workers? So if we drop it down, it's going to take more. If we increase the number of workers, it's going to take less. So I don't know. I'm not going to try to figure that out. I just need to figure out my equation. So my equation is going to be K divided by X because it's inversely related. The more workers, the less time. So my Y is 20. My K, I don't know, figuring it out. And my X is 5. Multiply the 5 over. Cancel it out. K equals 100. So that might actually, in this one, represent the total number of hours it would take to complete this job. So if I go back over here, we could start this process over. My equation now is 100 divided by whatever our new X is. And our X represented the number of people. So we're looking at Y equals 3 workers. So 100 divided by 3. So if I throw that in the calculator, it's going to get me a 33.333333. So we'll just say, oops, 33.3 hours. Nope. Yeah. All right. So with a 3-person crew, we can get that thing done in 33.3 hours. If you have an 8-person crew, you're still taking 100 total hours, I think, that it should take to finish the job, but now it's 8 people working on it. So if you divide that, you'll get 12.5 hours. Okay, and that was inversely related equations. So again, as one value goes up, it causes another value to go down, and that is your generic equation every single time. They'll give you a sample X and Y, plug it in to figure out what this K is. And again, sometimes I can make sense of that K and sometimes I can't. Either way, it doesn't matter. That just gives me my new equation that now I can get any kind of an X thrown my way and figure out what my Y value is. All right, that was inverse proportions, inverse variations.